So in this video, we're going to warm up with simplifying expressions. And you can see here there are some variables, there are some numbers here, and it's written as a fraction. And so if it's written this way, it's kind of implying that there is division. And so this goes back into quotient rule. And quotient rule says that if you have something on top and something on bottom, and they have the same base, so in this case, they're both an x, then you can subtract the top exponent from the bottom exponent. So let's try to apply that here. Let's first look at the constants. So this is a 4 and this is an 8. If we were just to reduce this like a normal fraction, we would ask ourselves, okay, what goes into 4 and 8? And it is 4. So 4 divides into 4 one time and 4 divides into 8 two times. So we can reduce that down. We can also see that there is an x and an x and a y and a y. So that y is to the first power, since it's not written, I'm going to write it in. So I really have 1 over 2, or 1/2, x 4 minus 3, and y 3 minus 1. So I'm subtracting the exponent, and I'm going to clean it up just a little bit. So this x is 4 minus 3, so that's just 1, or x to the first power. And this y here is 3 minus 1, so that's going to leave me with a 2 as an exponent. And from here, I can't combine an x and a y anymore, and so there's nothing more I can combine. This is my final answer. Let's try out this one here. So this one's a little bit tricky. Anytime we have y to the negative 1 power, just remember that you have something that has a negative exponent, and so whenever you have a negative exponent, you need to put it back into the denominator. And so we really have x squared, but I'm going to put the y in the denominator so it can be a positive 1 exponent. So if you have a negative exponent, you can put it in the denominator, and that will help it become positive, because negative exponents just mean take the reciprocal, so it flips, and that's why it's in the denominator now. And I can leave my answer like this because I can't combine an x and y, so there's nothing more I can do. And so that's going to be my final answer. So we've done these problems before, but we're going to be working with more complicated fractions, as you can see down below. And we're going to need to simplify them using some of the skills we've learned in the past. All right, let's take a look at maybe example 1. So example 1 here has, let's see, 1, 2, 3 terms on top, because they're separated by the minus and plus signs. So there are 3 terms, and then 1 term in the bottom. So there's a rule that basically says that if they are all connected by one denominator here, you can actually separate the top by that denominator. And this is how you do it. So basically, I can give the first term 3x, let me do that in a regular color. So 3xy to the third, and put that over xy. And I'm going to write out my minus sign, x2y over xy, plus 2xy squared over xy. So hopefully you've noticed that what I've done is taken each term and give it its own denominator with the same denominator that I'm using. So this is perfectly legal to do, and this actually helps make the problem a little bit simpler to handle. So what I can do is just focus on each fraction one at a time and reduce it like I did in the warm-up problem. So like the first thing I notice is that there's a 3 here, so I'm going to ignore that because there's nothing I can simplify in the denominator. But both of these have an x. So anytime both of them have an x, they actually cancel. So both of them had an x to the first power, so they completely cancel. Because, well, if you have x divided by x, it just becomes 1. And so if you have 2 variables with the same power, they can cancel. Whereas the y's don't cancel because this y is to the first power. So this ends up being, let's see, 3y squared, because 3 minus 1 is 2. And so this part is simplified, the x canceled, and this is all I have left. I'll bring down the minus sign. Now I notice with this one, I have x divided by x to the first power. So this has a square. So 2 minus 1 makes this x to the first power. And the y's cancel because they're both to the first power. So the y's completely cancel here. I'm going to bring down the next plus sign. The 2 comes down since there's nothing to divide with. The x's cancel here. And then this y is to the first power. And so y squared divided by y is going to end up being just y to the first power. From here, it looks like I can't combine anything because these y's are, this one's squared and this one's to the first power, so they are not like terms because they're different powers or different exponent. So that's it. That is my final answer. So I can't do much more because everything is a positive exponent and I can't combine any like terms. All right, moving on to part B. So part B looks tricky because you have this one here. It looks like a multiplication problem, like you're multiplying this factor with this. So really, anytime you have a negative exponent, remember, we can always write it in the denominator to make it back to a positive exponent. So what I'm going to do is write this in the denominator, make a really big fraction, because I want to put this on top, because notice this exponent here doesn't have a negative exponent, it's just a positive exponent. So this whole factor here gets to still stay on the top. And so when I see it written like this, where this is now in the denominator, and like, oh, this is like the exact same problem I had before, I have three terms here. I'm going to separate it using the denominator that I have. So I'm going to give each term its own denominator to make this process a little bit easier for me to handle the exponents. So from here, I notice that this is a 4 and this is a 2, so I could reduce that. They both divide by 2, so this will end up being 2 and this is 1. So I have 2 here, and this is an a squared and this is a to the first. So that ends up being a to the first power because 2 minus 1 is 1. The b's cancel, so I'm just going to completely wipe that out and bring down the minus sign. That's next. Now this one gets interesting because you'll notice that everything cancels out here. The top and bottom are exactly the same. But if everything cancels out, it doesn't mean that your answer is 0 here. It means that it's 1, right? If everything divides evenly, that means if you have the same thing on top, same thing on bottom, and if you divide, you always get 1. So I'm going to bring down the minus sign. And then 8 and 2 both divide by 2. So 2 goes into 8 4 times, 2 goes into 2 1 time. The a's cancel here, so I would have a 4. A's cancel, and then b is squared on top, and b is to the first power on the bottom. So this ends up being b, 4b. And from here, I can't combine anything because they're not like terms, so I can leave my answer like this. Ooh, I think I forgot something. This was a plus sign. I just noticed right there's a plus sign, and I forgot to drop it down as a plus sign. You guys probably noticed it before I did. My bad. So it looks like I really have 2a plus 1 minus 4b, and this would be my final answer. Okay, so let's try out a few more before we move on to the topic. So this one here, pretty much the same. There are only 2 terms here, so I'm going to separate this using a denominator for each. So this one has a 24 and this has an 8. They both divide by 8. So 8 goes into 24 3 times. 8 goes into 8 1 time. It looks like I'll get 3a squared because this a is to the first power. So 3 minus 1 is 2. And then this b here has a square and the bottom has a 1, so this will be b to the first power. And then drop down my minus sign. This is a 16 and 8, so that divides by both 8. So this will be a 2, this will be a 1. That will give me a 2, a to the first power, since the bottom is a to the first power. So a squared minus a to the first power will end up being a to the first. This b is to the first power, so 3 minus 1 gives me 2. So this will be b to the second power. And then these are also not like terms because this a is not squared while this one is. So this is my final answer. I can't combine anything else. And I have no negative exponents, so this is fine. All right, last one here. Again, I'm going to separate the top with its own denominator. And I have 3 terms on the top. So from here, I'm going to try to cancel out anything I see. Like the 5's here is cancel, the y's cancel. And this x on the bottom is to the first power, so x squared divided by x to the first is just going to be x. Minus this 10 and 5 both divide by 5, so this will end up being 2, and this will end up being 1. Looks like the x's cancel and the y's cancel, so I am just left with 2. I'll bring down the plus sign here, and this is a 15 and 5, so they both divide by 5, so this will end up being 3 and 1. The x's cancel, this y's to the first, so this ends up being 3y to the first power, because 2 minus 1 is 1. Okay, and I think this is my final answer. Oh, by the way, some people like to rearrange it in order of like their highest power. So some people like to write the y like in order of the alphabet. So they might write this as x plus 3y minus 2 instead, but there's no preference. Both of these are good and valid answers. But yes, some people like to write the constant at the very end of the expression. That's perfectly fine to do if you want to rearrange things, but that's not needed. All right, in the next video, we'll look at something called synthetic division.